When we talk about Hadoop 2.x, the first striking feature should come to mind is yarn, which is for yet another resource negotiator. It is also called as MapReduce 2.0 or MRV2. Right now, yarn is characterized as a large-scale distributed operating system for big data applications. There were many shortcomings in the Hadoop's initial version, which were well addressed in Hadoop 2.x version. For example, introduction of yarn, introduction of high availability, introduction of HDFS federation. These are some striking features which were added to Hadoop 2.x. As we know, MRV1 consists of job tracker and a task tracker for a processing framework. Scheduling and resource management were two responsibilities of job tracker, which were divided into yarn. In yarn, resource manager has a scheduler which allocates resources to various applications. Node manager is responsible for launching application containers and monitoring the resource usage. While application master is a virtual entity which is initialized in a container only when job is submitted to the cluster. Yarn supports multi-tenancy. It means it can run multiple access engines like MapReduce, Graph onto a same cluster. Scalability also supported in Yarn, as well as dynamic allocation of cluster resources improved as compared to Hadoop 1.x. And it also provides backward compatibility support for MRV1 jobs. It means if you have the application which is running MRV1 jobs onto a cluster and if you upgrade it to Hadoop 2.x, you can still run the MRV1 jobs onto the newly improved cluster, that is Hadoop 2.x. So let's see how yarn works, how it allocates resources, etc. in detail. So you can see the resources available to resource manager. Onto the diagram is around 96 GB of memory as well as 48 cores of CPU. So how they are calculated? They are calculated as the summation of all the nodes available in a cluster. Each node has 16 cores as well as 32 GB of memory. Therefore, resource manager has 48 cores as well as 96 GB for allocation of jobs onto a cluster. In Yarn, whenever a job or a task is requested by a client to run on a cluster, it goes to resource manager, which allocates resources depending on the requirement of a job or a task. An application is a Yarn client program that is made up of one or more tasks. For each running application, an application master helps coordinate tasks on a cluster. Application master is actually a first process run after application starts. The application starts and talks to resource manager for a cluster. resource manager makes the single container request on behalf of application. At this point of time, application master starts running within that container. Then application master requests subsequent containers from resource manager to run actual tasks for the application. So here you can see resource manager has initialized one application master on one of the node or a machine, which ultimately initialized another container on a different machine. So once all tasks are finished, the application master exits and last container deallocated from a cluster, and at the same time application task or a client also exits. So this is how the yarn processing works.